Well, hi, and welcome to the second half of Chapter 10. I'm sorry, Chapter 11, where we're going to continue on with kind of quick review from last week. We did how do you handle exceptions, errors, while basically coding. And as we found out, we're able to capture any exceptions and deal with those as opposed to just letting it blow up and show some red text to the user. So we're going to finish this chapter, and the second part of this chapter starts getting into the different ways we can read some of the different files. So it talks about binary files, random access files, and object serialization. So the first thing it talks about is binary files, and really what they're talking about there is when we read a textual file, what we're doing is just reading it as a string. It's just text. So if you think about each character is basically a bunch of ones and zeros. And so there's a bunch of those ones and zeros put together to make up one word and a sentence and so on and so forth. Well, when we store something in binary format, let me back up a little bit. So when we go to read that textual file, well, what does a computer understand? Well, a computer understands ones and zeros. It's binary. So what we have to do is we have to convert that textual file into a binary file, or binary data, I should say. The program, the computer, they read it, and then it basically spits it back out as textual. So there's a couple, 3 or 4 different steps that going on there just to read the data, display it, deal with it, so on and so forth. But what if we were able to read the data in as binary and write it out as binary? We can actually save a few steps by doing that. So to do that, we can create these things called binary files. So that's kind of where the section 11.3 gets into. And it talks about if we were to store the number 1297, well, textually it would store it as this, okay? Just characters. And each one of those characters would basically be a bunch of binary numbers. Whereas if we stored it as a binary, it would basically look like this, okay? So that's the binary representation of 1297. So to do that, we have a couple of different classes that we have to utilize, and these are stored in the java.io package. And if you remember from previous chapters, we can actually include those by doing the import. The first one is called the file output stream. This allows us to write data out to a binary format. It says it provides only the basic functionality for writing bytes to the file. In order to basically get the full binary file representation, we also need this thing called the data output stream. This allows you to write data of any primitive types or string objects to a primitive file. Okay, we don't use it directly, but we use it in conjunction with the file output stream. So here's kind of a quick little example. I've got file output stream, and that's my class, and the object I'm creating is the f stream, and we're instantiating it as a new file output stream with this textual line of data, which is basically the name of the file. And then I do a data output stream. That's the class. The object is the output file, and we instantiate that as a new output stream, f stream. So we're basically taking this stream and then basically writing it. Okay. So the first line creates an instance of the file output stream class, which has the ability to open a file for binary output and establish connection with it. You pass the name of that file you wish to open as a string to the constructor. The second line creates an instance of the data output stream object that is connected to the file output stream referenced by fstream. The result of the statement is that the output file variable will reference an object that is able to write binary data to the myinfo.dat file. So there is no reason to reference the file output stream object. Then these statements can be combined into one as follows. So data output stream output file equals new data output stream, and inside of this I can just say new file output stream myinfo.dat. So it's kind of a nice quick way to take those two lines of code and put it into one. Once we have the data output stream object, once it's created, we have some different methods that we can utilize to basically utilize this particular object. So I can close. Now the void means that's what's being returned from the method. So we can close it. We can write Boolean, but we have to pass it a Boolean. We can write a byte, but we have to pass it a byte. We can write a char. We have to pass in a char. Write double, write float, write int, write long, write short, write to UTF. So which is a Unicode text format. And whenever we utilize one of those, we have to make sure that if we're writing a double, we have to pass in a double. So let's go ahead and take a look at this very first program example, which is called the write binary file. Notice up here at the top, I do have the import java.io. I do have my public static void main. I create an array. It's an integer array. The name of this array is called numbers, and we go ahead and load it with 2, 4, 6, 8, 10, 12, 14. And then I create my file outputs fstream, which is a new file, which is numbers.dat, and data output stream. So we basically go ahead and create the data output stream. We create it from the fstream. We go ahead and display, writing the numbers to the output file, and it says we go ahead and create a loop that says for int I equals 0. So that's what we're going to do in the beginning, and then while this statement is true, I is less than numbers dot length, so the number of elements in there, which is 1, 2, 3, 4, 5, 6, 7. Every time we get through the loop, we add 1 to I. And so we go ahead and say output file. So here's my output file right here, which is a data output stream, dot write int, and I'm passing in an int. And then I basically, once it's done with that loop, I go ahead and display the word done, and then we go ahead and close the file. So this is one of those programs that nothing spectacular happens. So I go ahead and run it, and it says writing the numbers to the file, and it's done. Now if I go out and I can see here's that numbers.dat, and I can see when it was ran, I double click on it, I open it, and it looks like a bunch of gobbledygook. Well, what's going on there is it wrote that out as binary data. Well, binary data, we can't read it natively, so what happens is the notepad tries to open it as best it knows, and it combines those binary numbers together and says, oh, that looks like this, that looks like this. So there must have been some non-printable character there, and it thought, oh, that just happens to be, we put those binary numbers together, it happens to be an arrow pointing up. So there's a whole bunch of data going on there, but the text editor doesn't know what to do with it. So it goes, I'm going to make a best guess and hopefully do it okay. So that file is stored in a binary format. Now if I need to read it in a binary format, it's already there, because again, I can read it in as text, but I have to convert it to binary, deal with it, and then convert it back to binary. Okay, so so now we're going to read data in. So we've seen how we can write it out. How do we read this data in? Well, I got a file input stream and a data input stream. So they pretty much work in conjunction identically to the ones we just talked about. So I have to, the file input deals with the file, and then the data input stream says I don't deal with files directly, so what you're going to do is you're going to pass a file input stream to me, and I'm going to deal with it. And again, it's pretty much has the same type of methods that the output has as well. So we've got close, we've got read Boolean, read byte, read double, boom, boom, boom. So notice that these are kind of a vice versa effect here, meaning that when I read a Boolean, I'm not reading anything into my parameters, but I am spitting a Boolean out. So it allows me to read it, and it knows that it's going to produce a Boolean. So here's my read binary file. So we take a look at that, and here I've got my public static void main. Notice I do have a throws clause in there, because since we are opening a file, we always want to make sure we deal with any exceptions for that. So I have my file input stream, fstream, is equal to or instantiated as a new file input stream, numbers.dat. So this is that numbers.dat file we just created. Then I go ahead and create my data input stream, which is an input file, and I instantiate it as a new data input stream, and I basically utilize that fstream that was just created. And I say while not end of file. Now, what is end of file? Up here, notice that it is a Boolean, and it's been set to false. So while end of file is not false, I want to try number equals input file read int. So number is an int, and I equals to the input file. So here's my input file dot read int. And again, it's the reads are going to return whatever data type it's basically calling there. So this is a input file read int. It's going to return an int. So then it goes and does a print number, and it's going to display space and then that number. Okay. I'm sorry, it's going to display the number and then a space. If we happen to get any exceptions, our catch will catch the end of file exception, and in this case it will return the end of file equals true. So in this case, we're actually wanting it to blow up at the end of file, where we go ahead and set that equal to true, which will make us get out of the loop. So kind of a weird way to use an exception, but it's perfectly legal. I'm going to let the exception blow up the program, and then which causes it to set a flag and get us out of the loop. And then we go ahead and display done. We go ahead and close the file, and basically the program is over. So I go ahead and run it. Notice this is reading the number from the file, 24681214, and then says done. Now notice that the system out is a print, not a println. A println would put them on separate lines. We have a space after the number. That's so we have these spaces in between the numbers that are displayed on the out. Okay, so pretty straightforward stuff. It's able to read a binary file and then spit it out as a string. Okay, so continuing on, we can also append data to a existing binary file. If you pass the same name of the existing file to the file's output stream, it will erase and a new empty file will be of the same name will be created. Sometimes, however, you want to preserve an existing file, meaning you want to append to the end of it. The file output stream constructor takes an optional second argument, which must be a Boolean value. So notice right here I've got file output stream fstream equals new file output stream, and there I've got myinfo.dat. So that's the same exact file. Now I want to output to it. Well, if I did not have this comma true on there, it would basically create it as a brand new file. So if there's already one there, it's wiped away. If I have comma true on there, it will go ahead and append to the end of that. So for a quick example, what I can do is, here's that right, and I can actually put a comma true right here, and I can actually, well, we'll just go ahead and append the same numbers on there. So I go ahead and save it. I go ahead and run it. I go ahead and then come over here to my read. I'm going to do a read, and look at that, 24681214, 24681214. So again, the comma true allows me to append to that file. Okay, so random access files, those are a neat file. So what we just covered was a file output stream and data output stream. So data output streams, if you remember what the old cassettes did, cassette tapes, we could play them, but if I needed to get to song number 4, I literally had to fast forward to that song. So I had to move past the other 2 songs to get to that song. Well, in today's world, we have CDs and MP3 players and all those kind of neat things, and I can actually go directly to that song. That's basically what a random access file is. A random access file allows us to go directly to a record in a file. If I want to read record 4, I can just say read record 4 and it brings it back. The data output stream, I have to read records 1, 2, and 3 to get to number 4. So random access files, very, very powerful. So, and that's kind of what this example is talking about here. So in a sequential file, to get to this file right here, I have to basically read, and then finally read that file. Well, random access, I can actually go here, jump around, however I need to do it. So to utilize it, I use a random access file, and inside of its constructor, it has a string, which is the file name, and a string, which is the mode. Okay, mode meaning, are you doing a read, are you doing a write, are you doing a read write, so on and so forth. So that's kind of what they're doing down here. We got random access file, random file is instantiated as a new random access file, mydat.dat, that's the name of the file, and we're going to do an R, which is just a read. Or I can do a RW, which is a read write. So if we look at write letters, so here again, there's my class write letters, public static void main. So here is a char array. It's called letters, and notice we have all of the letters of the alphabet with basically individualized one at a time. I go ahead and print, opening the file, and then I've got random access file, random file, instantiated as a new random access file, letters.dat, that's the name of the file, and read write. I've got system.out println, I say, which says writing data to the file. Then I've got my for loop. So I instantiate the I as an int and initialize to 0. While I is less than letters.length, and at the end of every loop I'm going to add 1 to I. So I say random file.write char letters I. So it goes ahead and writes a char. Okay. What are all the different writes that are out there? Well, looks like we've got a write byte, write int, write boolean, write char, write chars, write double, write float, write int, write long, write short, write UTF. So kind of the same sort of thing that we saw in the previous example. Well, we can specify what data type we're writing to this guy. So if I were to write this or run this, it says open the file, writing data to the file, and then done. So the name of that file is called letters.dat. And if I look over here at letters.dat, yep, I just ran it. And there's the letters of the alphabet. Notice I do have a space in front of the A. And why is that? Well, I think that's because of the I think it's the characteristics of the random access file, is it goes ahead and puts spacing between the different items there. So, because I think it believes it has different tags for knowing when it's the next record and the end of file, that type of thing. Okay, so is there a read random access file? Wow, look at that. Here's read random letters. So here I've got a final int char size equals 2. So we're basically got a constant called char size that's set to 2. We've got a long, which is called a byte num, and then we've got a char, which is ch. Okay. Random access file, new random access file letters.dat, comma r. That means we're just reading this guy. We're not writing to it. We got byte num equals char size equals 5. So byte num, which is a long, is equal to char size times 5. So we take this char size, multiply it times 5. This is move the character 5. This is the 6th character from the beginning of the files. Okay, so read the character stored in this location. Char equals random file dot char read char. And we go ahead and print that char. Move to character 10. So again, So right here, random file.seek bytenum. So what it did is it just went to that position, which happens to be position char size time, which is position 10, and read that char. Then we go ahead and say byte num equals char size times 10. So 2 times 10 is 20. And we go ahead and random seek.bytenum. Now it's going to go to the 20th position and bring back that particular guy and display it as well. We do char size times 3. 2 times 3 is 6. It looks at the 6th position, brings that back. And then finally when we get done, we say random file e.close. I go ahead and run this. And it was F, K, and D. So that is the 10th, the 20th, and the 6th position. A, B, D. Right. The reason it's doing the 2 is because of those two spacings there. So right here, the random access file treats a file as a stream of bytes. The bytes are numbered, and the first byte being 0. The last byte of this number is one of less than the number of bytes in the file. So the random access file keeps a long integer value known as the file pointer. The file pointer holds the byte number of the location in the file. When a file is first open, the file pointer is 0 for the very first position. As it's read from byte, when an item is read from the file, it is read from the byte that the file pointer points to. Reading also causes, so that's basically what we're doing when we do this seek. We're placing it in a certain position. So to kind of follow up on the 2 characters each, there on page 739 it says, the seek methods move the file pointer to the byte number 49, which is the 50th byte in our file. Then the read int method is called. This reads the int from the file. And an int is 4 bytes in size. So the statement reads 4 bytes, beginning at byte 49. For example, let's call a program and 11 rote letters to the alphabet, the letters .dat. Let's say the first letter is a 0, the second letter is a 1, and so on and so forth. Suppose we want to read character 5, the 6th letter of the file. At first we might want to attempt the following code, which is seek 5. Although this code will compile and run, you might be surprised at the result. Recall that the write char method writes a character as 2 bytes, because each character occupies 2 bytes in a file. The 6th character begins at byte 10, not byte 5. This is illustrated in this figure 1116. So if we come over here, character 0 is at position 0 and 1. Character 1 is at 2 and 3, so on and so forth. To determine the position of a character in the file, that's why we multiplied by 2, and we basically ran that, because if I tried to grab position 5, again there would be gobbledygook in there, because that's part that a char takes up 2 bytes. To determine the position of character in the file, we must take each character's size into account. The following code will correctly read and display the 6th character to determine it. So let's read random letters. So well, I just did that. So we just read each letter, and that's basically why we had to multiply by 2 in order for that to happen. Okay, so so we talk about this thing called object serialization. Now, so object serialization, we've kind of sort of seen this when we call methods and call a method inside of the same class run, where it's basically made static, which says static says it's ready to use right out of the box. We don't have to do any instantiation, it's just ready to go. Well, serialization is kind of sort of the same in the fact that it kind of converts everything to binary so that we can use it right out of the box. So Java allows you to serialize objects, which is a simpler way of saving objects to a file. So another way to think of serialization is I need to transport data over a long distance. To do that, I really need to send a series of ones and zeros and basically get that data so that it collects it on the other end very, very easily. So whenever I do that, I need to serialize the data. So when an object is serialized, it's converted into a series of bytes that contain the object's data. If the object is set up properly, even the other objects that might contain as fields are automatically serialized. Okay, so if I serialize a file, the fields are automatically serialized as well. The resulting set of bytes can be saved to a file for later retrieval. In order for an object to be serialized, its class must implement, if you remember from chapter 10 where we do inheritance, you must inherit a serialization interface. The serialization interface, which is in the Java I/O package, has no methods or fields. It is only used to let Java compiler know that the objects of the class might be serialized. In addition, this class, if a class contains objects of other classes as fields, those classes must also implement the serialization interface. For example, in this chapter source code folder, there's a modified version of the bank account class called bank account 2. The only modification to this class is that it implements a serializable interface. Here's the modified line of the code. Import java.io serializable. Public class bank account 2 implements serializable. This new code tells the compiler that we want to be able to serialize the objects. So it says we may want to, we may not. We don't have to, but we say we may want to serialize objects. To write a serialized object to a file, use the object output stream. The object output stream class is designed to perform the serialization process, converting objects to bytes. To write the bytes to a file, you must also use the output stream object such as the file output stream. Here's an example. File output stream, output stream. So here's our class, here's our object. We're going to instantiate it as a new file output stream, and the name of the file is called objects.dat. Then I take and I create an object output stream. The output file is a new object output stream. So again, this is the serialization process. Okay, so this guy right here. To serialize an object or write to the file, the object streams class write object method is shown here. So here I've got my bank account 2. I instantiate it. The object is account, and I instantiate it as a new bank account with 5,000, which is a double in the constructor. The object output file dot write object account. The write object method throws an IO exception if an error occurs. The process of reading a serialization object's byte and constructing an object from them is known as deserialization. So if I'm reading in a serialized file, so it's all bytes, binary, and I want to write it out, I have to convert it to that string. So I deserialize it. It's called deserialization. So I've got file input stream and instream instantiated as a new file input stream, and here's the name of the file. Object input stream. So up here we had object output stream. So object input stream, object input file. So the same of the object is instantiated as a new object input stream, and I'm basically bringing in this file input stream. To read a serialized object from the file, use the object input streams class's read object. So I would say account equals account. So basically here I'm basically making it, I'm using the case here, which says, hey, take this guy and convert it to a bank account 2 object. So the object input file dot read object. So it deserializes that and throws it into account. But this guy right here, again, it converts it to a bank account object 2 first. Okay. The read object method returns a deserialized object. Notice that you must cast. I'm sorry, that's called casting. You must not casting. You must cast the return value to its desired type. So again, we read it, we cast it as a bank account 2, and throw it into account. Okay, so let's take a look at this program, which is the serialized object program. So again, I've got public class serialized objects. I've got a public static void main. Again, I do have a throw IO exception because I am reading and writing output files. I've got a scanner keyboard. Here's my bank account 2. Notice it's got these square brackets, which means it's an array. The name of this array is called accounts, it will hold bank account 2 objects. And we instantiate as a new bank account 2, and we got num items, which happens to be 3. So I got a for loop here. I create an integer I, initialize it to 0, and then while I is less than accounts.length, which is 3, I'm going to keep doing this, and then at the end of every loop I'm going to add 1 to I. So I go ahead and print into the balance for the account, and it's got I plus 1 because again I don't want to display 0, I want to display 1, 2, 3 instead of 0, 1, 2, and then it basically puts a colon at the end of that. So and then I type in the balance. It goes through again, does the same thing, so I'm going to type in 3 different balances, and each time it says accounts, which happens to be a bank account 2 object, is equal to a new bank account 2 balance. Before we go on down, let's take a look at bank account 2. So if I look at bank account 2, it's a class and it implements serializable. Now again, that's an interface that has no methods inside of it. It just tells the JVM, the Java Virtual Machine, that this object can contain serialized objects. Doesn't have to, but it can. So I come back over here and I've got my file output stream. And it's going to write it. It's going to basically write it out to objects.dat, and then my object output stream, which deals with serializable items, object output file, and then it goes ahead and writes out the out stream to the serialized output object. Then we go ahead and write it out via a for loop. Okay, so again, it goes through this for loop and it does an object output file dot write object, and it goes ahead and writes. It grabs each element out of the array and writes it out. And then once we're done, we close it, and then basically at the end we say the serialized objects are written to the objects.dat file. Okay, so not much to see here, but we're going to go ahead and run it, and I'm going to write the balance out for each one of these guys. And it says they were basically entered. So if I go ahead and take a look at the objects.dat, if I open it up, notice that it has a bunch of gobbledygook in here. We see the word bank account 2 and we see balance, but that's about the only thing. The rest of it is all gobbledygook because it is binary. So it's binary data being displayed, but we do have the bank account 2 as textual items in there. So I think we're going to do a read of it. So let's take a look at the book. So here's our deserialized objects. So we go ahead and let's take a look at deserialized objects, which is going to be the actual read of it. So I should say we display it out. So here I've got my double balance. I do have a constant called num items that's equal to 3. Here's my file input stream, and the object name is going to be instream, so we instantiate as a new file input stream objects.dat, so we're reading it in, and here's my object input stream. So this is where this is kind of where I deserialize it right here by bringing in the end stream, which is a file input stream. Bank account 2 accounts, new bank account 2 num int. So basically allows me to create an array of bank account 2 objects. The name of that array is called accounts, pretty much just like the same in the last one. Instantiate as new bank account 2, and it's going to have 3 items. I got a for loop. I say accounts I is equal to bank account. So basically this is where I read the item, deserialize it, I cast it as a bank account 2 object, and throw it into accounts I. Okay? First time through 0, 1, 2, and then I go ahead and close that file, and then I go ahead and go through another for loop to display them down in my console. So I count I plus 1 again, because I don't want to do 0, 1, 2. I want to do 1, 2, 3. And it goes and displays the balance of each one of those accounts. So notice before I had 500, 1500, 2000. So if I run this, let's see what we get. There's my 500, 1500, and 2000. So again, we just look at the objects.dat. It was a bunch of gobbledygook because, again, it's binary. So we read it as a binary because it was serialized. We deserialize it so we can spit it back out and display it to our users. So again, serialization allows us to take a file and put it into a binary format so that we don't have to spend time converting it from one to the other all the time. It's pretty much in that spot and also it transports easier. And we can send it across the line and the network a lot easier in a binary format as opposed to a textual format. So a lot of good things about serialization. It does everything behind the scenes for us. We really don't see anything in the foreground. We don't get to see and touch and feel serialization because it is in a file format. So we really don't have to worry about worry about physically seeing serialization. It's all done for us behind the scenes. Serializing aggregate objects meaning adding one on top of the other. If a class implements a serializable interface, then all the fields in that class must be serializable. So again, all of the variables in that particular item that class will be serialized as well. So just realize that when using serialization. So in order to basically get the data out, we have to do a deserialization. Okay, so we're going to basically take a break right there before we continue on to the next section. So we'll see you in a bit.